like it means nothing.
All right, welcome to the email lecture, the most exciting topic of the conference, maybe. But we all use email. It has existed forever on the internet, and I think it will live for a long time. So we wanted to update you on the current situation of different kinds of attacks and defense methods, and give some advice how you can make your emails work better for you in different situations and companies and others. So what is this IKI thing? It's a non-profit society in Finland. We have about 30,000 members. The main thing you get is a permanent address, something at iki.fi. And it's actually really convenient that the address stays the same, so you don't need to register with different address to different place or something, and it's not going to change. IKI does not provide email services or web services. We forward your email to some other place, and we forward your IKI web address somewhere. And we have also been very active in internet active advocacy and email standardization process and other things. And so based on that, let's jump right in. So we all know email in our normal email app. Maybe for many it's Outlook or something, sorry about that. And the good situation is that 5 years ago, 10 years ago, we were struggling a bit with spam. And the spam volume has kind of stabilized, and the spam filtering methods have become better. And today, the main problem is phishing, and especially spear phishing, which means targeted. Somebody wants to get to you to get something. It's not all good, though. So email is still the major entry point for malware and ransomware into organizations. You know that if somebody gets an email, they are going to read it, and if it looks like a real email, they will click the links and other stuff. Phishing is getting a lot better, and here better, I mean that it's better in phishing. So it's worse for the users. And what we have seen recently is with AI, you can customize each email for each recipient. And so the emails have changed to be a lot more relevant to something. And so it's harder to identify that something is wrong with this message. One big thing for companies is called business email compromise. This means that somebody wants to fake an email to the finance person where the CEO says that wire $1 million to this account or something. And because it's from the CEO and it's internal and it's all secure, then maybe the money goes away. And this has been pretty bad in the recent years, and we are seeing a lot more things like corporate email systems filtering based on the links, and even when you click a link, it will still go through a checking process to try to catch this kind of thing. One of the challenges for email is that people read email on all kinds of devices. You have email on your computer, you have email on your smartphone, you have email in your tablet at home, and so there are so many places where you might kind of not be totally concentrated and get something. So very interesting that change, this I think is a quite general malware change. What they are trying to do these days is they try to steal your credentials, session cookies, and especially something like your Microsoft 365 login session information, because that gives the attacker a huge attack surface to go for, and maybe the user doesn't notice anything. One creative way we have seen this being used is for business email compromise. So if somebody sends you an email from outside, it goes through all kinds of filtering and security. But if I have the user's credentials, I can open their inbox and put the message right in, passing all the security that there might be. And so the bad guys always use all the cool stuff that we think about. This is very well known for the email professionals, but this is the most common question we have to explain to people who are not email administrators when they are having some email problems. And it's very kind of, it's unintuitive and people don't know that it works this way. So there are some addresses in the inside of the body of the email from to, you see this every day. And, you know, that looks nice. But actually the email is not sent or transmitted using these addresses at all, except when you send the email originally. So for example, when you do BCC, so blind carbon copy, the system will take the addresses from that, add them to the recipient list, and then delete the BCC line. But then kind of all the real email activities happen using what are called envelope addresses. And this is what happens on the SMTP, Simple Mail Transfer Protocol, that maybe was simple someday. And this is what happens, is that you connect to a mail server. Is it internal or external or the recipient's one? And you say, here is email from this address, and the email is going to these addresses. And then you give the content, and the content is the text, including the from and to headers. But the content of the content is not used for anything, except for content filtering. So of course, when spam filtering looks at the message, it will look at that content as well. And some of the methods we will talk about in a moment, they do require that the visible from, which is what the user can see, these envelope addresses, the email admin can see, the user can see that if they are not afraid opening the headers of their email sometimes. But you know, the from address is something that everybody understands, to address. And some of these methods want to match the envelope address to the visible address. But this is very common that you need to, so when you talk to your email administrators, they want to somehow get in connection with the envelope addresses and all that kind of email server log stuff, which might be totally different from the visible stuff. And to demonstrate this, I just wanted to do this. If you're some very young person, you might not have heard about Telnet, and then just use NC when you try this. And so, but this is also something interesting that email standards, they follow the simple IETF methods, so they are text-based. They are actually usable. So for example, here, the Joulupukki coin, which must be a super reliable meme coin, wants to send an email. So the content could be kind of anything, but you see that I connect to the email server. I say I'm Joulupuki coin, and in this case it will accept it because I'm on the same machine, and send it to this guy. And then I type the message, and as you can see, so in the beginning we have this mail from, received to. That's the envelope address. That's what is really used to deliver the email. And then inside the email, you can have some entertaining from, to, and other headers that makes it better. So I tried this 2 days ago, and I thought, surely this cannot work anymore. And I got this. Happily, it went to the spam box, but here are actually a couple of interesting questions. So Apple Mail thought that, hey, this looks like spam, so be careful. You can also see that the to address, it has identified that my email address is in my contact, so it shows my name instead of this much cooler name of where is it? To future millionaire. That would be much better, maybe. But so email applications are doing a lot of things like this. And there are a couple of big ones: Gmail, Gmail app, Gmail web, Outlook, and some others, Apple Mail. And then there are like hundreds of other email apps, and they all work a bit differently with all of this. So if you are a company sending email to your customers, it's really hard to predict what will happen to your emails, because the different services, different applications will show them a bit differently. We will get to the point where we have some recommendations, and if you follow those, then your emails will very likely get through, and people will be able to see them. Okay, so there are many ways people have tried to protect the user from spam, or authenticate the sending server, or authenticate email somehow. And one of them was SPF, Sender Policy Framework, I think originally from Microsoft. And I had some things here so you can just have a feel that typically these protocols, they have in the domain name system some information where it's coming from, what is used by the system. And the idea of SPF is that you list the servers that send email for you, and then the recipient can check if the email came from the same place. Well, there are like a million use cases where the email does not come directly to you. It goes somewhere, and it then comes to you, and SPF will fail. So we will come back to DMARC in a moment. So especially if you would be using SPF to protect your email users for receiving email, today SPF alone is not really recommended. You need to use the couple of better methods. And also when you're sending, you should go beyond this. And so there are a lot of problems with this, mailing lists and all kinds of things. But a lot of people say, hey, this is great. And they are like, if I put this in, it will eliminate all spam. One, this doesn't identify spam. It identifies that the email came from some server, which might maybe be relevant, but a lot of email come from other places. Here is also an interesting topic. So you can see that if SPF fails, in the SPF you can say hard fail, maybe fail, I don't do something, and then there is this fuck you, so you should, even if SPF fails, you should accept everything. And people often choose the strictest option from this kind of configurations, and that's often not at all the right thing to do. So we found out in Iki, because we are kind of idealistic nerds, we put, of course, the plus all in our SPF, and then we found out that a lot of places are thinking, if you have plus all, we will just block you. So then we could not use that either. And the bad thing here is that if you use SPF only, sending or receiving, which is kind of the way people did 10 years ago, it's going to be bad. Then, even if you can verify the domain, a lot of spam has valid domain validation. So spammers use your own domain, temporary domain. You have to wait for 24 hours after registering the domain before sending email, because many places block email from new domains. But, instead of trying to fake some domain name, just register something nearby and use that, and you can set all these security features for your own domain. And then we will come back to this, but it's very convenient to use some cloud services to send spam or phishing, and we'll come back to that. So a portion of spam, we actually did some statistics just a moment ago, maybe 10 or 20% comes from the major cloud services. So there are convenient places of running things, so people run their spam bots there. Then there are a couple of really interesting ways to abuse Outlook 365 users, because in practice, almost every company is in this system. They are using Outlook and Microsoft 365. And if you are using Outlook and 365, the instructions say that add this include into your SPF settings. But what happens? That include brings in about 470,000 IP4 addresses and 10 to the power of 24 IP6 addresses. Do you really trust all of those to send email as you? But the creative way of using this is, if you have two companies who are in Microsoft Cloud, and you want to fake a message from one company to the other, what you can do is that you set up forwarding from your whatever Outlook account to the target address. Then you send a fake message that has from and everything from the fake sender. And when it gets to the recipient, because it comes from a Microsoft service, it comes from those IP addresses and everything, the targeting user probably, and the systems will think, hey, this is actually a real email from this other company. So that's quite interesting, I would say. Okay, then better methods for protecting your email. And this is for senders to help receivers identify the messages being real. And so this is DKIM. And the point is that you put in your DNS some encryption keys, and then you sign your email. You have these DKIM signature headers. You sign your email saying that these headers, this content, actually was sent at this time from this domain really, and here is some cryptographic signature saying that actually you can trust this. And this is very good. So if you are sending emails, definitely do DKIM. In most mail server softwares, you just need to kind of click that. You have to make the certificates, and then you click Turn DKIM on. And It really helps the people on the other side to figure out that the email is from a real place. And so the idea for this is that the receiver will look at the incoming message. They can verify that it actually came from this place. The message content, optionally, has not been modified, and that's really good. But, of course, even here you can do some interesting things. So, for example, something that people found out is that DKIM allows multiple signatures. So you could have another signature from somewhere to signing some additional headers, for example, changing the job subject or something. And if you didn't sign the body, you could also change that. And what the bad guys do, they get one real email from some web shop or something to their own address, and then they just replace some fields in it, and they spam that out, and for a short time window, everybody will think that it's from the original place. There are a couple of methods to avoid this, and here we talk about these oversigned key headers. So it says here like subject, subject, date, date, and so on. This will stop people from adding any new headers. But if you have an old DKIM implementation, you want to double check that you have this turned on. Okay, then for the receivers, but also for the senders. So DMARC, where there is now a new version being worked on, DMARC 2 at IETF. I'll come back to those in a moment. So this is something that you can use SPF and DKIM, and then DMARC allows you to say that, I'm using these. If they match, if they don't match, what to do. And an interesting feature in this, which is not really widely used, is that you can ask for statistical samples of emails that don't match your rules. So you might get feedback from kind of messages that somebody gets that are not from you, and you can see kind of what kind of things our customers are getting. So that's quite useful. But so this will require DKIM and SPF. DKIM is the most important one because it protects the email content itself, not just some IP address that can change at any time and so on. But even in DMARC, there are some people who try to sell DMARC services who say, just implement the strictest way and you will totally block spam or something. And the important thing here is that the DMARC sender can say that if the DMARC check does not succeed, they can choose one of the options is reject, which means that you should just drop the email. But as with the other standards, there is a lot of kind of broken stuff in email. So if you go with the strict options here, you might end up rejecting real email. And so kind of the best practice is that use DMARC, but even if the DMARC fails, you still have content filtering and all kinds of stuff, malware analysis. Just run that and use the DMARC as one of the inputs to your system. And so that's one of the key parts. Each of these tries to do one thing, but you also need to have a kind of defense in depth with different methods, content analysis and link analysis and other things. I'm not going to go into those today because they're kind of above the protocol level. Okay, then one thing that is reasonably new is ARC, Authenticated Received Chain. This gives you an option of signing that, hey, I got this email. When I got it, SPF was correct, DKIM was correct, DMARC was correct, and now I send it to you. And if you trust me, then you can kind of trust that those informations might be correct. The challenge here is that there is no trust store for this, but we have had some luck of saying to people that, hey, at IKI we do this, and maybe you could just put somewhere that if you get ARC from IKI, you could kind of trust it. And then you make a backroom deal at IETF conference or something, and then the emails start working better. But this is something that I will come to the forwarding use cases in a moment. And so you need some method of saying, I want to trust these intermediaries. Mail goes somewhere and comes to me. So how to do that? Then, best practices. Sending email, and this is important for companies. Every company is sending email to your customers, and you want the email to go through. So the big email providers like Google, Microsoft, Yahoo maybe, they have their own guidelines, and you should read those and follow them. Don't use SPF only, that's outdated. DKIM sign all email going out. Use DMARC. The situation right as of today is that if you are using DKIM and DMARC, maybe SPF as a kind of backup of a backup, actually your email will get through pretty well if your content is not too marketese. And one point here is that because these standards use information in domain name system, it would actually be a really good idea to use the DNSSEC domain name system security to protect your domain name records. And well, we all know that the domain name system has been repurposed for a million things. Then some interesting topics for IP address management. Today, so the receivers kind of try to look at the reputation of each IP address or a IP address block. And so, for example, if you're an ISP, send your corporate emails from a different address compared to the address where your customer emails go. The customers will send out all kinds of junk, and you want your mails to go through, so put it in a different address block and send your emails from that. So then that block will get better reputation, and your important customer emails will go through. And people have seen an interesting problem with cloud services. If you get a server in the cloud, it could have been used by a spammer 5 minutes ago, and you try to send email to somebody, and everybody will block you. So pay for the static IPs or something, I guess. Okay, then if you are the receiving email provider, so this could be the IT department of your company, IT department of an internet service provider, university or something, who is providing email access to their users. So you have to work around these stupid ways of using these standards. So if SPF fails, don't panic, use the other filtering, and if the other filtering says it's okay, just let it through. Because there is so much email where for one reason or another, the SPF fails. Of course, use the DMARC and DKIM when you receive emails, and check those and use them to analyze the email. And then preferred domain, not IP address based reputation systems. I think this is even more important now with IPv6 because there are just so many of those buggers. And then your job is to get your users to get their important emails. And unfortunately, a lot of those emails are kind of spammy. From a web shop or airline, capitals only, maybe with some problem in the email headers. And you should look at those and just let them go through, because otherwise the users will come to you and say, hey, I didn't get my important email. And one thing to consider is, instead of blocking, provide some kind of quarantine service. So put the email somewhere, and the user can go to some quarantine mailbox, and they will learn quite quickly that if the porn website login information didn't come through, maybe it's here in the quarantine place. But it will protect the normal users, so if they are not looking for that message, they will not see it. And then you can ask your users, are there some senders, some organizations, or somebody who is forwarding email to you that you should support better so that your users get email. The users know pretty well where the emails come from, and they will be able to provide this information to you. Okay, then this annoying word, intermediaries. I try to avoid saying forwarding like Iki is doing, because what we have found out is that there are a huge number of use cases. Maybe actually the biggest use case is web hosting companies, where you host your domain and somebody sends email to that domain, and it will forward the email to your other personal email address. This is super common for small companies around the world. And then there are, of course, all these different things like university alumni, connectivity sites, other professional organizations, places where people forward their email. Users also configure their own forwarding. So, for example, they might forward some emails from their desktop email address to their mobile phone email address for a trip or something like that. So it's very common to have this thing that the email doesn't come directly to you. And this is the major problem for SPF. We're not talking mailing lists here, because it's a completely different can of worms with many worms in the can. But people who run mailing lists, including the IETF itself, who makes the standards, have had trouble running mailing lists. So, that's something. But also, if you are providing some service like this, let's say you are an ISP providing web hosting, and you forward emails to their users, be careful. So especially, do not break the good standards. So do not break DKIM. This mainly means that don't change anything in the email. Add the ARC signature. It seems to be starting to be used more in the receiver side. You can also do spam filtering on the email that passes through you. We don't know, but it seems that, well, like Google or Microsoft Outlook email, nobody knows how they work, but people try to figure out how they work. So if you do spam filtering, and then you add a header that says, I think this is spam, and it was analyzed by me, it seems to work better. So even if you send spam to some, like Gmail, if you send spam that says, I think this is spam, they will keep your reputation better. SPF people always say that, just use this sender rewriting scheme. Please don't, it doesn't help, and it breaks DMARC, which is the good thing, so don't break good things. So one big question is, so the amazing thing about email is that even today, anybody can get on the internet, put the computer on the internet, run an email service on that, get the domain name, and they will be able to send and receive emails. So there is no gatekeeper, there is no control, and this is really the power of email, that it's a super open ecosystem. But if you look today, so for individuals, Gmail has grabbed a huge part of the market. And for companies, Microsoft services have grabbed a huge part of the market. So there is kind of a couple of big ones, and then some smaller ones, and then everybody else. And I think this is a political and technical problem. So I mentioned this that because we don't know what they do exactly, for example, if Gmail changes their filtering on the Christmas Eve, you need to figure out what did they change, what might work, but I think the good thing here is, so you need to follow what they require. Happily, they have pretty good guidance, but it doesn't include all the details. So if you start getting a lot of problems from one of these big guys, you need to look at your logs and see what's going on. The good thing is that if you use DMARC and DKIM, you are pretty well set for these big ones today, but it might change tomorrow. And then a portion of spam, as I mentioned, comes from the big cloud services, and it has a valid email signature from that service. So that's even easier for the spammer than setting up their own server or something. Email security. Email as it is does not have any security, but some years ago, maybe 10, 15 years ago, there was a huge increase in practical email security. All the email servers were changed to encrypt the connections by default. It's not authenticated, but it means that if you are listening on the backbone internet, you don't get clear text emails anymore. You need to do an active attack to get somebody's emails. And this, I think, has been the big improvement. There has been several tries to secure email. SMIME, almost all email apps support that. PGP, nobody even remembers that anymore. And they're just too hard to use for normal users. One thing I would like to mention here is kind of the secure email services that send you a link. By clicking that link, you go to a web page that shows you the content, but it means that anybody who received that email could click on the link. Okay, maybe then the real recipient will notice that it has already been read or something, but it's not really. I think it's more like a checkbox security feature. Did you secure your email? Yes, we use this secure service. One of the big problems, I would say that the major problems for email users are the problems in email apps, email applications. So the email application user interface is a major problem for a lot of these. So for example, a lot of the apps will show just your secure bank and not the spammer at evil.com, because our users want to get friendly names and things like that. So even if the users wanted to look at it a bit, they can't. Okay, a bit about the email infrastructure. There are commercial and open source and other solutions. Of course, a lot of people outsource these services to the big guys because it's just so easy. And then there might be some non-profit where people do this kind of stuff for free as volunteers. But if you are an internet service provider and you provide email service, it does create a support load, and it costs real money and something, but email is really important for people. And these days, often people say that, Gmail is never going to go away, but remember how many Google services have disappeared over the years? Or maybe they don't delete it, they add some aggressive marketing or spying or something, or they make it paid, so you never know what's going to happen. Okay, then, if you are working with email, what places we have found to be super useful to follow? So one is the IETF. Those are the cool nerds that build all the Internet Protocol specifications. And the best part of this, it's free. You can join mailing lists. You can join the conferences remotely for free. And so there are lots of email standards. All the standards I mentioned, except SRS, are from IETF. New version of DMARC is coming someday, but you can think maybe it will take a couple of years. There is a mail maintenance group where people can discuss what do we need to change to go forward. There is also a group revising the core email specifications. And this is easy. You join some mailing lists. If it was not the right one, leave and join another one. Then something that we have found super useful. So if you are a company sending email to your customers, receiving email to your users, like an internet service provider, there is this little-known group called Messaging Mobile Malware Anti-Abuse Working Group. They don't really share outside much, that's what they do. But there are a lot of people from all of these stakeholders. And for example, there are some mailing lists. Hey, we saw this problem with Gmail today. And then people say, hey, we saw the same. We think the reason is this. And maybe you can solve the problem in a couple of hours instead of trying to hit your head against the wall. It is paid, so something, but we have seen that this is super useful for kind of keeping up to date with the things are happening, and don't use non-proprietary, non-standards. Okay, so what did we talk about? Email is the ultimate example of an open standard. Anybody can join, and it still connects people from very old things. I think the good example here that people use that does this still work, you have like some 20-year-old webcam that sends super broken emails with broken JPEGs, and you want to make sure that those pictures get to the user. But there is a lot of this compatibility, and all of these other options are built on top of the basic functionality. And also the open standard ecosystem helps avoid lock-in to one provider email or identity, because it's very important that the email address is often your main identity on the internet, if for nothing else, for resetting your password in some other service or something like that. A lot of things still fall back on email, so if nothing else works, you can use that to get back. There are some interesting things coming, because we are in Finland and we like our characters. So email address internationalization means that you can put weird characters and whatever language, whatever is in Unicode. It does include emojis, so you can have emoji at domain. And that's kind of standardized, and it's kind of, how do we get that out? Do we want to really get that out or something?
Then there is for companies who send email, there is this project and specification called BIMI, Brand Indicators for Message Identification, where if you pay for your certificate, you can put a special signed file on your web server and add something to your emails, and then some email apps might show your company logo next to your email. And DMARC 2 is coming out, so if you do with email, it's worth following that. So thank you, and keep calm and keep using email. Thank you.